In this video, we're going to talk about the special angles. Oops. So let's do some recall. If two angles of a triangle are equal, then the sine opposites to them are also equal, such as this one. This side is alpha, the opposite side, let's say, is A. This side is beta, the opposite side is B. If the angle angle alpha is equal to the angle beta, then the side A is equal to the side B. This is true for all of the triangle. The second thing I want to recall is if we are in a 13-degree, 16-degree, and 19-degree triangle, the opposite side of the 13-degree angle is half the length of the hypotenuse This is only true in a 60-degree and the 19-degree triangle. So which is here. So here we got a triangle. (13°). So that means this side, this is 13°. So that means the opposite side of the 13°, if this side equals to A, then the hypotenuse is equal to 2A. Another thing I want to remind is the Pythagorean theorem. The Pythagorean theorem says that the square of two sides of a right triangle is equal to the square of the hypotenuse. That's Pythagorean theorem. Now let's start with our special angle. So we suppose have a 13°, 16°, and 19° triangle. And let's draw this in a here 13° or 16°. So this one is 13° and this is 16°. So in this 13°, 16°, and 19° triangle, right now I will try to use both the radian notation and also the degree notation, so you can transition this in between. I want you to get more familiar with the radians notation. So 60° is what? Pi over 3, and 13° is pi over 6, and 19° is half pi, which is pi over 2. All right, so if the 13° sine, so let's say the opposite sine of the 13°, which is pi over 6, is, let's say, s, then the hypotenuse by this theorem is equal to 2s. So how do we find out the other side? We can apply the Pythagorean theorem. We know that x squared plus something x squared, the sign that we don't know, is equal to 2s squared. Now simplify it. We have x squared plus x squared equals to 4x squared, right? and then we move it to one side. I have x squared equals to 4x squared minus x squared on both sides, right? So that means on the right side is equals to 3x squared. Okay, and then our x is equal to what? We take square root on both sides, so we have square root of 3. X squared takes square root is equal to s. So that means the third side is equal to s. Square root of 3s. So this is very important to know how to get this sign, because later we need to memorize all of the sine 60 degree equals to what, cosine 16 degree equals to what. If you don't remember the sine ratio is 1, square root of 3 and 2, then you can use the Pythagorean theorem to find out what's the third side equals to. But the first thing you need to remember is in a 13, 16, and 19 degree triangle, the opposite side of a 13 degree angle is half the length of the hypotenuse. Once you know that, you can find out the length of the third side. Okay, so in the future, I'm not going to show you this. I'll just go by 1, square root of 3, and 2. Okay, so now let's try this. Sine 13 degree, which is our sine pi over 6 equals what? By the definition, sine is the opposite side over the hypotenuse. The opposite side of 13 degree is equal to 1. The hypotenuse is equal to 2. So that means sine 13 degree is equal to 1/2. Now, next one. Sine 60 degree, which is our sine. Let's do all sine, cosine. Let's do all 13 degree first. Okay, next, what's cosine of 13 degree? Cosine of 13 degree also is pi over 6, which is the adjacent side over the hypotenuse, which is square root of 3 over 2. Next is tangent 13 degree. Tangent 13 degree is also tangent pi over 6 is equal to the opposite, which is 1 over the adjacent, square root of 3. So in math, we don't keep the square root in the denominator. We need to simplify it. Simplify is equal to the square root of 3 over 3. Okay, next one is sine 60 degree, which is our sine pi over 3. So sine pi over 3 is equal to the opposite of the 60 degree over the hypotenuse, which is square root of 3 over 2. Then we have a cosine 60 degree. It's equal to the cosine pi over 3. So this is equal to the adjacent side of the 60 degree, which is 1 over the hypotenuse, which is 2. And then tangent 60 degree is equal to tangent pi over 6, which is square root of 3 over 1, which is, simplify it, square root of 3. Okay, so here is the special angles, 13 degree and the 60 degree, the sine, cosine, tangents. Then next, go ahead and take a look at the 45 degree one. So if it's in a right triangle, if I have a 45 degree right triangle, which is here, so if this is a 45 degree, 45 degree is pi over 4. If these two is equal, the opposite side are also equal. So that means this sign is A, this sign is also A. So how do I find out the hypotenuse? The hypotenuse is equal to the sum of the two sides squared equals to the hypotenuse square. So simplify, I have a 2a squared equals x squared, and take square root on both sides, so I have a square root of 2, a is equals to x. So here's square root of 2 of a. So again, if you remember that if two sides of a triangle is equal, then the sine opposite to them are also equal. Then you will be able to find the hypotenuse. Okay, next. Now let's try the sine pi over 4 is equal to what? The opposite side, which is 8 over the hypotenuse square root of 2 times a. That got cancelled, so I have 1 over square root of 2. Simplify it, I have square root 2 over 1. Over 2. Now, next one is cosine pi over 4, which is the opposite side, which is 8 over square root of 2 times a. Here is equal to 1 over square root of 2. Simplify it, I have square root of 2 over 2. Next is tangent pi over 4. I will have the opposite side over the hypotenuse. Opposite side over the adjacent side, which is a over a. This is equal to 1. So here are our special angles, the 13 degree, 45 degree, and 60 degree. So when I was a student back in China in high school, we are required to memorize all of this. But now I don't want you to memorize tangent 45 degree equals to what, or sine 60 degree, or sine pi over 3 equals to what. No, all I want you to do is I want you to be able to prove it or show it by yourself by knowing this theorem that we learned before, which is the Pythagorean theorem. If the angle is 13, 6, and 19, then the opposite side of 13 angle is half the length of the hypotenuse. If the two angles are equal, then the opposite side are also equal. If you can remember that, you will be able to calculate what 13 degree equals to, 16 degree equals to, or tangent 45 degree equals to. So here are some exercises. I want you to find x and y in this given triangle. So I have a triangle, maybe a bigger one. Let's say this is pi over 3. Remember, pi over 3 is 60 degree. Now I want you to get more familiar with what is 60 degree. And how do I find x and y? Okay, so we know that if it's cosine pi over 3, it's going to equal to the adjacent side over the hypotenuse. If it's the sine pi over 3, is equal to the opposite side over the adjacent, sine is the opposite side over the hypotenuse. And if it's tangent pi over 3 is equal to the opposite over the adjacent side. Okay, so now which one we should use? Actually, we can use all of them, but the easy way to solve it is you pick thing that you just have one variable. For example, the second equation, sine, we have two variables, x and y, so that means we need to either solve x or solve a y first. The other thing can lead to a mistake is If you solve y wrong, that means if you use the sines function, it will lead to, you will get the x wrong too. So that means in this case, the best way to apply the trigonometry function is use cosine and tangent. And the cosine pi over 3 is equal to 2x. And from our previous calculation, we got that cosine pi over 3 is equal to, let's take a look, 1/2. And these two is equal. So that means because they both equal to cosine pi over 3, so that means I have 2 over x equals to 1/2. So we solve for x is equals to 4. So now we solve the first one, x equals to 4. Second one, tangent pi over 3, which is tangent 16 degree. And in the previous exercise, we know that tangent pi over 3 is equals to square root of 3. So that means these two equations are equal because they're both equal to pi, tangent pi over 3. So then I have y/2 is equal to square root of 3. So we solve for y is equals to 2 times square root of 3 by multiplying the 2 on both sides. So that's how we solve x and y. Okay, now the next one. So if you are calculating the special triangle, which is 30 degree, 45 degree, and 60 degree, I want you to keep the square root, which is square root of 3 or square root of 2. I don't need you to find out, hey, the square root of 2 is equal to 1.412, dun 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 dun, and solve the accurate answer. This is not going to be accurate. If you let this equal to 1.412, this is an approximate answer. The accurate answer should be square root of 2. So keep it in this way. It's okay to keep square root of 3. Okay, the next one is, what if this is not special angle? Such as in a triangle like this. This is x, y, 3, and this is 15 degree. How do we solve it? So similar to the last one, it's better for us to use cosine 15 degree equals to, and the tangent 15 degree, because cosine 15 degree is equal to the adjacent sine 3 over the hypotenuse x, and the tangent 15 degree is the adjacent sine, no, the opposite side over the adjacent side. So we want to just keep it with one variable. But we never talked about how to find the cosine 15 degree. Here, I want to teach you how to do it with a calculator. Okay, so to calculate the cosine 15 degree, all you need to do is go to type Google, and then type in sine or cosine or tangent, cosine parentheses 50. But if it's just 15, the default will be the radians, which is they will consider this is 15 pi instead of 15 degree. So you need to type in degree, and then they will give you the answer, which is 0.642787. And the next thing that I want you to keep that in mind is make sure that you put in degree instead of the radians. Similar to tangent, like tangent 15 degree, they give you the answer is equal to 1.197, because when you type in 15, tangent 15 is different than tangent 15 degree. We need to have the degree. See, if it's tangent 50 is equal to negative 0.27, so this should be the degree. So here, let me copy this down. You can also use a decimal. Later I will attach a YouTube video on how to use the decimal to calculate the cosine and sine function. Okay, so here I have a cosine 50 is equals to 1.197, and no, sorry, tangent 15 degree is equals to 1.917, and the cosine 15 degree is equal to 0.6427. Point 64278. Okay, so that's how you use a Google calculator to calculate the degree. So after I copy this down, I can solve x. X is going to equal to 3 divided by cosine 15 degree, which is equal to 4.667. And our y is equal to 3 times tangent 15 degree, and this is equal to 3.5753. So that's how we calculate the answer. So x is equal to 4.667, y is equal to 3.5753. Okay. That's it for this video. We talked about the special triangle and how to use technology such as Google Translator and Decimal to calculate the degree that is not in a special triangle. But remember, if it comes to the 13 degree, 45 degree, and 16 degree, I want you to keep the square root instead of calculate into a decimal places. Okay, that's it for today. See you in the next class.